In this video, we're going to talk about scientific mathematics, mostly units and significant figures, and we'll explain why those are important as we go through this lecture. So, most scientists use what is called the International System of Units. And the International System of Units is based on the metric system. And we abbreviate the International System of Units as SI. As I said, it's based on the metric system, so not miles and pounds and gallons like we're used to, but liters and grams and kilograms and kilometers. And it uses what we call prefix multipliers with the standard metric units to change the value of the unit by powers of 10. So, for example, kilo means 1,000. So if we use the prefix kilo with the length unit of a meter, the units become kilometers or kilometers, however you want to say it. That means that a kilometer is 1,000 meters. Okay, let's do another example. Centi means 0.01. And so if we use centa with meters, it is 0.01 or 10 to the minus 2 of a meter. So the way we know it's 10 to the minus 2 is because we have 2 decimal places. So that gives us the 10 to the minus 2. That's, excuse me, that is a very brief explanation. We'll talk more about how to use those powers of 10 in a few more lectures when we get to scientific notation. So centimeters are a smaller unit of measurement than meters because there are 100 centimeters in 1 meter. So here we have a table of the prefix multipliers, and you can see 10 to the 12th, or a 1 with 12 zeros after it, has the prefix tera, and we use the symbol T. So in case you're wondering, 10 to the 12th is what we call a trillion. Going down, giga is billion. Mega is million. Kilo is thousand. Deci is tenth. Centa is hundredth. Milli is thousandth. Then we have millionths, which is micro. Nano is billionths. And pico is trillionths. So how do we know which one of these prefix multipliers to use? Well, we usually use one that is close to the size of the quantity being measured. So for example, what units should we use to report the distance your car traveled on the way to work? Well, usually for that, hopefully, well, we use miles, but the rest of the world uses kilometers, which we abbreviate K, lowercase k, and M, K for kilo, M for meters. Okay, we're going to not do 2 because that was an ill-conceived problem. We would end up with terakilometers, which makes no sense. So what unit should we use to report the diameter of an atom? Well, if you want, you can use your phone or your computer and look up the average diameter of an atom. And what you will find is that the average is somewhere around 0.5 nanometers. So 0.5 nanometers is a very, very tiny number. You see, we have one half of 1/1000th of a meter is what a nanometer is. And nanometers we would abbreviate with a lowercase n for nano and then an m for meters. Okay, scrolling to the next page. We need to talk about some unit conversions. So, sometimes in science it's necessary to convert from one unit to another, or in mathematics. Sometimes, especially if we have a word problem, they may mix the units on us. So the converting from one unit to another may be from one prefix to another, like between kilowatts and megawatts, or between units in different systems, like converting pounds to kilograms, for example. So let's convert 154 centimeters to inches. And note, we have 1 inch equals 2.5 centimeters. So I always start with what I know, what I'm trying to convert. So I'm trying to convert 154 centimeters. Now I'm going to multiply that by my conversion factor. So my conversion is 1 inch equals 2.54 centimeters. Okay, since we have centimeters that we started with, we need to have centimeters in the denominator of our conversion factor. And 2.54 centimeters, we have said, is 1 inch. So now we do 154 times 1 inch divided by 2.54 centimeters. So what happens here? Well, the centimeters cancel each other out and we're left with inches, which is good because that's what we're supposed to be converting to. So now we just do the math, and 154 divided by 2.54 leaves us with 60.6 inches. Okay, what about kilograms to grams? So there's 2 ways to do that. The first way is just like we did before. So we have 3.14 kilograms. And as we discussed on the previous page, 1,000 grams is 1 kilogram. So you notice this time, since I started with kilograms, I put the kilogram in the bottom. So this time, the kilograms cancel. And if we multiply, we end up with 3,140 grams. The second way to do this, we'll talk more about later when we learn more about scientific notation. But since we know that kilograms is 10 to the third, we can look at the 3, and since it's positive, that means we're going to move the decimal point in our 3.14 3 times to the right. So 1, 2, 3. Now you'll notice this third move has no number in it. So we have to put a 0 in there. And our decimal point has now moved to right there. So our answer is 3,140 grams. So there's 2 ways to do that. Either one is acceptable. Okay, now let's try converting 1 million miles to the most appropriate SI units. We usually use kilometers to change miles. So let's go with 1 million miles. And we have that 1 kilometer is 0.62 miles approximately. So miles goes in the denominator. And the 1 kilometer goes in the numerator. And so again, the miles cancel. And if we use our calculator to crunch the numbers, no, I'm not going to expect you to do that without a calculator. We have 1,612,903.226 kilometers. Okay, I just wrote that down all willy-nilly. It's an approximate answer. When you do science, we need to talk about significant figures. These are important. So doing scientific experiments involves measuring different quantities. So how do we know how certain or how precise our measurements are? Well, scientific measures are reported so that every digit is certain, except for the rightmost one. And that one is estimated. So the precision of a measurement is crucial for scientific measurements and is represented by what we call significant figures, or sometimes we also use the word digits. So significant figures, significant digits, the same thing. So the greater number of significant digits in a measurement, the more precise that measurement is. So it's critical when we do mathematics that we do not lose any precision when we do the calculations. And so that gives us a list of rules. And we'll pick up those rules in the next video.